Hi students, today we are going to solve one CBSE numerical. The question is, a 100 turn closely wound circular coil of radius 5 cm has magnetic field of 3.14 into 10 raised to minus 3 Tesla at its center. The current flowing through the coil and the magnitude of the magnetic moment of this coil are respectively two values are there in each option. We want to find the correct option. Okay, option number 1, 2, 3, 4. I am not reading option now. First option, for example, 2.5 ampere and 2 ampere meter square. So we can do one drawing first. This is that coil. Assume this is that coil, and axis I marked. And how many turns are there? 100 turns written. And the radius of this solenoid is 5 centimeter. One more information given, right? Magnetic field at the center of the coil, 3.14 into 10 raised to minus 3 Tesla given. So B is equal to 3.14 into 10 raised to minus 3 Tesla. Okay. So this many data given. So we will start the calculation for which two values? Current flowing through the coil we want to find. Also the magnetic moment we want to find. As I am saying always, what do we want to do? Read the question twice, thrice. How many times you want to read until you understand what is the question. Then what do you do next one? Write to the given values. What are the values given here? Number of turns given, right? 100 I can say there. So number of turns, which letter we are using? Capital letter N. Total number of turns N is equal to 100. Magnetic field also given. Radius of the coil also given. So radius is equal to R is using capital letter R, I am using 5 centimeter. Okay, in terms of meter, 5 into 10 raised to minus 2 meter. Now what next? Magnetic field given. Magnetic field is B is equal to 3.14 into 10 raised to minus 3, I think. Yeah, minus 3. So which equation we will use now? Solenoid subject, the derivation we did before. If you search my videos, you will find that one. Self-inductance of a solenoid and mutual inductance also, both are done. Okay. So magnetic field is 3.14 into 10 raised to minus 3. Now this is the time to find the current. How to find the current? Using the expression what we know already. That is one expression we studied before, that we are going to write now. So step 1, find the current. Step 1, find the current using the formula. Which formula we know? Self-inductance or mutual inductance? Of course, self-inductance, because there is only one coil, right? So find the current using the formula for the magnetic field at the center of a coil. At the center of a coil. So magnetic field equation, okay? Writing. Screen not scrolling, there is some technical issue. So the equation is B is equal to mu 0 Ni divided by 2R. See, all the values are given except I value. Mu 0 value was given in the question, I did not read for you that time. Okay. B is equal to mu 0 Ni. Yeah, B is equal to 3 into 10 raised to, 3.14 into 10 raised to minus 3 is equal to mu 0 value. Mu 0 value will be given in the first page of the question paper also. 4 pi into 10 raised to minus 7. Okay. Now N, 100 given, into I not given, divided by 2 into the radius of the coil given, 5 into 10 raised to minus 2 in terms of meter. What do you do next? Our target is to find the value of I. So cross multiply. Okay, cross multiply until you make I is equal to. Okay. So 3.14 into 10 raised to minus 3 is equal to 4 into that pi value I am writing, 3.14 into 10 raised to minus 7. There is a reason for that, because we can cancel, into 10 raised to 100 into, okay, everything written, yeah, 100 into. Now 3.14 cancel. Then what do you do next one? We can take the right side denominator to the left side. So 10 into 10 raised to minus 2. What answer you are expecting? If you are not doing that is in decimal, 10 raised to minus 2 you can take to the numerator. So it will become 10 raised to plus 2. So denominator there is only 110 exists. Okay. You have two options. One option is take that one to numerator. Other option is cross multiply to other side. Both are acceptable. Okay. So after doing the mathematical work, you will find that there's a I missing. I will write the I into I. So 4 into 10 raised to minus 3 in the numerator divided by 10. So I is equal to right side. This 10 is taking to left side. So 10 raised to minus 3 into 10 divided by 4 into 10 raised to minus 3. So 10 raised to minus 3 in the denominator, we can cancel with the numerator data, right? So 10 divided by 4 is equal to I. How simple now, you see. So is equal to 2.5. Mental calculation is fine. So current found it, 2.5. If you look into the answer key now, 4 options, right? 2 of them I expect most of the time they gave first answer is same. So we want to do the second calculation. Suppose out of 4 answer, current is equal to 2.5 only for 1, we can select to that one. 100% we cannot say, maybe we get a mistake, but there's a possibility. We will do the magnetic moment calculation now. So step 2 is calculate the magnetic moment of the coil. Calculate the magnetic moment of the coil. So equation required, magnetic moment. We discussed this one in the lesson. So magnetic moment equation is equal to NIA. Okay, NIA. N is the number of turns, I is the current, A is the area of the coil. So N is 100 into current is 2.5 and area is pi r square because radius given here. So cross sectional area will be pi r square. So pi into r is 5 into 10 raised to minus 2 square. So 100 is we can write like 10 square. 10 square into 2.5 into 3.14 into 5 square, that is 25 into 10 raised to minus 2 square is 10 raised to minus 4. Do the next level calculation now. Next level means the values. One is 2.5 into 3.14 you can calculate into 25. Okay, which is easy, that way you do. I suggest 2.5 into 3.14 into 25 into 10 power solve now. 10 raised to minus 4 plus 2. The answer will be minus 2. Now you can try actually. So somewhere in the rough calculation area you do the calculation of 2.5 into 25 first. See 25 into 2.5 easy, right? 2 times is 50. So 62.5 will come. 2.5 into 60 into 25 will be 62.5 into 3.14. Roughly do the calculation somewhere into 10 raised to minus 4. So answer of this one is 3 into 62, 186. So if you do the actual calculation, you will get 196 point, because 3.14 is there, 62.5 is there. So 196.25 into 10 raised to minus 2. In standard form it is 1.9625. That is 10 power adjusted. Okay. So close to 2 ampere. 2 ampere meter square. Now 2.5 we got before, 2 we got now. We will look into answer key now. Ready? Check which option is matching with us. Not second one, right? First one, 2.5 and 2. So first answer is the right answer. Okay students, thank you. Have a nice day. What do you feel? It was easy to solve, right? Thank you. Bye bye. എന്താണ് അങ്ങനെ കഴിഞ്ഞില്ല ക്ലാസ്?